All right. So, if I were to give you 2 points, meaning, let's take the point 4, 3 and 5, 6. Find the slope of that line. First thing you think is, well, I wish I had some graph paper, right? Because I would plot those points and find the slope. Because I know how to find it from a graph, right? So let's just do that real quick. Now, watch. You're going to be like so tricked out here for a second. Because when you do slope, you do rise over run first, right? So you're doing the up and down first. But when you go to plot points, what do you do first? The x first. So when I go to plot point 4, 3, I go 1, 2, 3, 4, 1, 2, 3, and I put a point right there. Okay? When I go to plot 5, 6, I go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and we're going to go up 1, 6. Okay? So let's just say that you could have chosen different points, but so what is the slope of this line right here? From here to here, now I go up 3 over 1, right? So I just proved to you that the slope of this line is 3, right? However, are you going to have graph paper handy every single time I give you 2 points? No, you're not. So there is a formula. And I know you learned it last year. Yes. And I know Mr. Meeks refers to it a lot as delta y over delta x, which means the change in y divided by the change in x, and that's true, but we got to get a little more detailed, okay? So let's do this real quick. The actual formula is y2 minus y1 divided by x2 minus x1. And that sounds so confusing. Did you learn this formula last year, or was it only written like this? Okay, so you're going to look at this and it's going to make perfect sense in about 30 seconds. So when you are given 2 points, x, y, and x, y, basically what we're doing is we're calling this point number 1 and this point number 2, right? So would you agree then that this is the x from point 1 and this is the y from point 1? And that this is the x from point 2 and this is the y from point 2? So I have my numbers. I know where they go. I just need to get them there now in the right spot. Because this is all about the right order. So what you'll see me do is this. You're taking this number and subtracting this number. And then you're taking this number and subtracting this number, right? So I did that backwards colors. I really wanted to do red and green. So because green was on top before. That's really going to bother me. So watch. We're going to try to fix this. Okay, so watch this. Take this number, which is 6, and subtract that number, which is 3. So your numerator and your change in your y's is 6 minus 3. Everybody okay with that? So because I went from 6 and subtracted 3, I have no choice. I have to do 5 minus 4. I can't do 4 minus 5. Both of my arrows have to be going the same way. Okay, are you okay with how I got these numbers into those spots? Okay, I did this y minus this y, this x minus this x, and 6 minus 3 is 3, and 5 minus 4 is 1, and what did we say the slope was from the graph? 3. So it matched, right? Good, because it should. So I will show you this real quick, though, because some people, for some reason, like that going backwards really bothers them. There are, you will never see me not go this way. But just like when you do the rise over the run, how you kind of have a choice, rather to go up and right or down and left, you have a choice here too. Could you do 3 minus 6 instead of 6 minus 3? And could you do 4 minus 5 instead of 5 minus 4? Sure, because both my arrows are going this way. Here's the danger in that, though. I'm going to tell you the danger. Okay, I want you to just think about this. On the side note, write the fraction 1/2. I know. You'll see why. You'll see why in a minute. That was actually intentional. Write 1/2. This is just an experiment. How many of you wrote the 2 first and then the 1? Okay, some people write the 2 first and the 1. When we write a fraction, isn't our instinct to just write the top number first, the numerator first, right? So, when we go from 4 to 5, where might we put that? In the numerator, right? But those are our x's. Those don't go in the numerator. Do you see what I'm saying? So if you can do that and know to put it here, go for it. But your instinct in all your years of fraction writing tells you, write the numerator first, write the numerator first. And I've seen it. Every time kids go this way, I get a reciprocal answer. Do you know what I mean? Their answer is flipped upside down because they put it in the wrong spot. So then the 3 and the 6 go here. And I want to show you what you'll get. You'll get -3 over -1, which is the same as 3, which gives you the same answer if you put them in the right spot. So you will always see me going from back to forward. And do you see why I put this in green now? Because I wanted the 3 minus 6 being the y's in the numerator. So,
wait, why is it 4 minus 3? You have 4 minus 5.
Oh, 4 minus 5, sorry. Okay, there we go. Sorry. Talking and writing. So that's -1, which then works. Okay? Thank you for correction. So just be careful how you choose to do it. You may need to play around a little bit to see which way works best for you. Try this one. Try 4,8 and 2,6. Go ahead and try that. And I have 2 more examples to show you, and we're done. So do however kind of makes sense to you. And for a while, these lines may be necessary for you. Maybe you understand it enough that, so do you have that? Are those in the right spots? Good. So this is going to give you -2 over -2. Your slope is 1. Okay. Now, beware. So put beware. We're switching holidays here. We're going from Christmas colors to Halloween. Scary. Beware of this. That negative is like the downfall for so many kids every year in these problems. I'll tell you why. Because you're doing 6 minus 2 and 4 minus -8, right? So 6 minus 2, and here's the thought process I can literally hear in some kids' mind when they do this. 4 minus, and then they go, oh, there's a minus, but sweet, I already got one there. And then they just put the 8. See why that's wrong? Because it's 4 minus -8. So I know the formula is minus, but you may see a plus. And you will see a plus when you are subtracting one of the negatives. So this is actually going to be 4 over 12, which is a slope of 1/3. Got it? So be careful of negatives. I have 2 more to show you. Next example. So that was 1 more, beware. How about 4, 3 and 2, 3? First thing you notice is both of the y coordinates are the same. Let's kind of see what happens there. So I have my 3 minus 3, and technically I could stop right there. I don't really even need to go anywhere. Because I don't care what the denominator is. Because if my numerator is 0, my answer is 0, right? But just finish it off. 2 minus 4 is -2, and 0 over -2, it's okay, right? It's 0 when it's on the top. So what is the last example that you think I'm going to do? Yep. So go ahead and see if you can do this one. It's not 0. It's not 1. It's, and you can just put UND if you want, undefined. Okay? Because when 0 is under, it's undefined. Okay, so what I need you to make sure you know is I can find slope from an equation. Either it's staring you in the face, or you got to solve for y and find it. Check. From a graph, do you know the rise over the run? Do you know when you go down you make it negative? Okay. And from 2 points. Got it? That is learning target 2. Those are all of the learning